Okay, I'll see on the screen. Okay, we are going to follow this the salary documentation, and one more documentation I have. I'll tell this Flask salary. This is about how you can use the salary with the Flask. This one. So we are going to use these two documents in order to set up our salary system. So, what is salary? So the salary is a like task queue. It manages the task, and you can use this to run the task asynchronously. Asynchronously means it will not it will not block the main thread. That is, you can run like four or five or n number of tasks parallelly, concurrently. So if you have the there are few use cases where you can use the salary. Like if you have a task which takes a lot of time in order to complete, so you don't want your application server to block, because if the server is blocked, the other users will not be able to make request to the your server because it's blocked. So I mean it is very, then it will become very hard to like scale your application. So what you would like to do, like you would like to run some tasks which are heavy tasks. By mean heavy task means the tasks which are heavy in computations, which will take a lot of time to complete in the background using the salary. And one more like use case of the salary is like not the salary, the salary beat is you can schedule some tasks. You can schedule some tasks that I want to do this task at some particular time, and the salary will like, let's say you want to send good morning every morning to some users. So you can schedule the task, and salary system is will be sending good morning to all the users to which you have configured. So there are two main concepts which you can use. Which you need to know before you start configuring the salary. The first one is message broker. The message broker is the like database which stores the messages which will be passed on to the tasks. And there is a result backend. The result backend, once the task is complete, salary system is going to send the result, like store the result in the result backend. So there are two things which the salary backend is like result backend is optional. Let's say you don't want to save the result of the task in your anywhere. Like let's there are some tasks in which you like the result, the storing of result is not required. Like if you want to send the email to some user, you don't want to like store anything in your database. Once the task is complete, like it will not return anything. But there are some use cases where you would like to store the result in the database once the task is complete. For example, let's say you have some calculation which which uh, like which results in some value, and once that task is complete, then once that calculation is complete, you want to store that result somewhere. So in that case you would require to configure the result backend. Other, it's optional, completely optional. So even if you don't configure the result backend, salary will still work. But the task queue is compulsory. What? But the broker URL is compulsory, because the it will store the messages which will be passed on to the tasks. So we will require two. So let me start with the user guide here. So start with the application. So I'll go to the configurations. documentation, and here I will go to backends and brokers. Getting started. Get started. First step is the salary. So let's start coding now. So this is the this is our virtual in this is the folder where we are going to write all our code. So this has a virtual environment. So I will be like installing all the dependencies. The first dependency I would like to uh, install in this local in virtual environment. First I'll activate that. Activate. System has become slow. I don't. Now the virtual environment is activated. Now I'll install pip install. I'll start with the Redis. So Redis we are going to use in order to store. We will use this Redis database as a message broker. As a message broker means all the messages that the task will require will be pushed to the Redis database. The first requirement, and then before that, let's start the Redis server. Redis server. So our Redis server is running on the port 6379. Okay, the Redis is installed. Let's install the Celery. Celery. So let's start writing the configuration. We will be writing all our configuration in this Celery config.py.
Hello, sir.
Yes,
Sir, can you do this in light mode?
light mode.
Uh, 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 Sir, in the VS Code.
In the VS Code,
Yes.
I'll have to change the configuration then. What's the issue?
Sir, this is in dark mode,
Yeah.
so can you switch to light mode?
Why is there any issue with this? Because
Uh,
I'll have to search how to change the like theme of the VS Code.
okay, sir. Okay. Then-
Okay, if it's not necessary, then let's
Okay, okay,
let it go. So
okay.
all the configuration I will write in this celery config.py file. First configuration I would like to write is broker URL. broker URL and a result backend. I'll just copy this. Okay. So the broker URL, as we discussed, like this is the message broker. So we are going to use this Redis as a message broker. Message broker means it will store all the messages which are required to run the task. So this will be the Redis database. As I don't know whether you guys know or not, the Redis is an index database. Index database means there are multiple like the Redis is index based. So this database has the index 1 and this database has the index 2, and this is the port where the Redis database is running. I'll show you quickly. So you can see that the Redis is running on the port 6379. That's why I have written 6379. Okay, so Redis is, I'll show the complete URL. You can see the Redis server is running on this port, and this is how you write the URL for the Redis localhost 6, and then you write the port, and then you write the index. If you want, you can use you can remove this index. Like if you want to remove, you can remove both these indexes, but it's better to keep these indexes. The broker URL where the message will be stored, and the result backend where the result of the task will be stored. Like the Celery will store the result of the task in this result backend. So we are using this broker and result backend both this the Celery, I mean the Redis database. We are using Redis database for both the broker and the result backend. Okay, let me check whether this has been installed or not. Yeah. So now the Celery is installed, Redis is installed. So let's start writing the code. So what I'll do, I'll create a file worker.py, and I'll create the Celery instance inside this worker.py file. So from Celery, Celery import Celery. Okay, this, and the way you create the instance is like, let's say I'm naming this Celery app is equal to Celery. So this is how you create a Celery instance. So once you have created the Celery instance, you and then you will load the configurations so that your Celery instance know which is the broker and which is the result backend. So I'll write Celery app dot what happened? Config from the object, and then I'll pass the name of this config file. Sorry, config. Now our Celery app knows what is the result backend and what is the broker URL. So I have loaded this configurations in our Celery app. Now let's create some tasks. Task.py. I'll write everything inside the task. I'll write all the tasks inside this task.py. So from what happened? There's something wrong with this. Okay, I'll give a brief overview again. So, so Celery is a system which distributes the task to multiple workers. So this is how you can summarize the Celery. And in order to work with the Celery, you need a message broker which will store the message which will be used in order to run the tasks. And you have multiple options for that broker, and one of them is Redis. So we are using the uh, Redis database, as a message broker. So this is how like this is the configuration which specifies that we are using the Redis as a message broker URL. And yeah, so this is broker URL, and result backend is the place where the Celery stores the result of the tasks. So once you push the task to the Celery computes the result, and that result will be stored inside this result backend, which is again the Redis database. And here inside the worker, I am creating the Celery instance. I have created the Celery instance, and it's very easy to create. You just have to import the Celery class, and then you can, like, this is how you create the Celery instance. So this is the Celery instance, and this is how you write the import the configurations which you have written inside this Celery config. And I am writing. There is a weird kind of sound coming. I don't know why. So inside the task.py, I am going to write all my tasks. So here, let me write a task from worker import Celery app, and then Celery app dot task. I don't know. Let me rejoin this meeting. I have no idea what is this sound. So Celery app dot task. I'll write the task. So let's create a simple task which will sum two numbers A and B, and then return A plus B. And then let's create a main.py where in future we are going to write our Flask application. So we are going to use this Celery app with the Flask, integrate this Celery app with the Flask application. So we are going to create our Flask instance inside this main app. So we have this task, we have this worker, and let's import worker from worker import uh, what was the Celery app, and from import tasks, I'll import all the tasks. Celery app, and I have imported all my tasks. Let's run this Celery app and see what happens. So the way you run the Celery app is equal to Celery. You first specify the Celery command, and then you write -a, and then you write your Celery instance name. So your Celery instance name is cell app, which is inside the main app, and then you write worker, which says that we are starting our workers, and then I'll set the log label info. So Celery command will start the Celery, and then we have this app, this -a, and then after that whatever we will write will be identified as a Celery instance. We have to give the Celery instance here. So this, by this word, mean that uh, this Celery app is our Celery instance, and this is inside this main module, and we are starting the worker, and this is, and the log label will be info. So let's try this. Let's see whether it runs or not. Okay. So the Celery has started. You can see that the name of this, if you want, you can rename this. You can see that the result backend is this database, and the broker URL is this database, and we can run 4 tasks concurrently, and then we have one task, tasks.sum. Like, this is the name of the task, and this is the name of the module in which this task is it's sitting. And then you can see it is giving some warning that whether broker connection retries are made during startup Celery above, you should set the broker connection retry on startup to true. So let's type this in our configuration, and it will suppress this warning. And then let's restart this. So let's restart this Celery app again. Like let's start the workers again. So last time we had this warning, and we are trying to suppress this warning. Okay, now this warning is not coming. So from here you can see that the message broker is this database, the result backend is this database, and we can run four concurrent tasks, and we have only one task, that is tasks.sum. Okay, so what we will do now, we will now we will install the Flask.
Hello, sir.
Yes,
Sir, can you show celeryworker.py file once?
okay. There is nothing there. The I have just created a Celery instance.
Yes, sir. Mine is given an error as celery config not defined.
So you're writing the exact same code.
Yes, sir. Can you repeat?
Are you writing the exact code?
Yes, sir.
I have just created a Celery instance and then loaded the configurations. That's it.
Okay, sir. I'll check. You please continue.
Okay, I'll post this code to the GitHub. You can check from there.
Yes, sir. Yes, sir.
Now the Flask is installed. So now let's create a Flask instance here. From Flask import Flask, and then I'll create an application Flask here name, and I have a Flask instance now. I'll define a route app.post. I'll be sending a post request here. Uh, slash sum. Okay, I'll make content this sum. I'll name this as a sum A and B, and then this is the sum, and then let's for now return hello. Hello, and then what I will do, I'll create one more. Okay, if name app.run, and then I'll keep the debug equal to true. Okay, let's run this Flask instance first, and uh, Python 3 main.py, which will run the Flask app. Okay, the Flask app is running now. Let's go and try to make a request, make a post request here. I will be using this Thunder client in order to make a post request. So create a new request, and I will local host 5000, and then what was the name of the endpoint sum, and I'll make a post request. Okay, let's go here, go to the code first. Here inside the main.py, I don't need this a and b. I am making the post request, so I will make this. So a is equal to, I'll import from Flask, I'll import the request. But this because it's not just a dot request dot form dot get, and then I'll a and b is equal to request dot form dot get b, and then what I'll do, I'll just return a plus b. So there is a weird sound coming from this from somewhere. I don't know from where it's coming, but yeah. Are you also listening that sound?
No, sir, no weird sound.
It's distracting. We will be going to 10.
Sir, it seems to be your background itself.
Inside the main.py. Let me. Okay, it's the new request is here. So let me make a request. See what happens. So type in the internal server error. Okay, it's not empty there. One A, one B. See what happens. Again started. I make that request again. Okay, it's not the query parameters. These are go to the body and then form, then fill name A, value 10, B, 20, and okay, it's working. So inside the main.py, I have this endpoint which takes the which like accept the post request, and so what I am trying to do is like I am trying to like run this sum as a background task. So inside this task, what I'll do, I'll just add a sleep here, import time, and I'll make this function sleep for 20 seconds. So let's not sleep this. What I will do is I will import tasks, and here what I'll do, I'll run these tasks here. S is equal to sum equal to tasks dot sum dot delay, and here what I'll do, I'll pass A and B and B, and that will run this sum task. So this is how you run a salary task. So there are multiple methods which you can use in order to run the salary task. I'll just give a quick overview. So running the salary worker, this is the running the salary worker, calling the task. So this is how you can either you can use the delay method, or you can use the what is that, async. First take to somebody running the task. You can use this apply async function. Either you can use this apply async function, and that delay function is just the shortcut for this apply async. But with the apply async, you can pass some more parameters, but we'll stick to this delay parameter because this is sufficient for our use case. So now what we are doing, we are passing we are running this task, and this task is coming from this, some task is coming from this tasks. So this is the salary task, and we are running this using this delay method, and this delay method is from the salary. So you specify your task, and then you use the delay method in order to run that task, and this will trigger a background job. And then let's return the test.id. Maybe I'll convert it in string. Okay, and now let's again make a request. Let's again make a request, and let's see what happens. You can see that we have received an ID. So this is the ID of the task which we have just triggered. And if you go to the go to here where you have run the salary, you can see that the task sum, this task is succeeded in this time, and here if you go look at this line, that the task dot sum is received. So as soon as you trigger that task, you will see this message, and then you have this one, like this message shows that this task has complete. So if you go and make some, I mean, sleep this function for 10 seconds, time dot sleep, let's sleep this for 30 seconds. I'll have to again restart this worker because we have changed the task, so we'll have to restart this worker. And this has, I don't know why system is running very slow. So the way you run this salary task, you write the keyword salary, and then you write the salary instance name, which is the salary app. The name of the instance is SCEL app, and it is inside this main module, and we have given this a flag which specifies that this is our salary app, and then we are trying to start the worker. That's why this worker, and when we will run the beat, this worker will change to the beat, and we want the salary to log onto the console. Say these messages are coming because we have set this flag, the log level, to info. So let's again start this, and then let's write one more function which will app dot get and then here what I'll do, get some get some, and then I'll get the ID, and this ID should be a variable part, and then get some, and then I'll receive the ID. So this will receive a get request, get some, and then what I'll do, I'll create a async function from salary dot results import async result. And what this async result will do, once you will pass the ID of some task, it will give you the like information about that task. So right now, if you look at this one, we have received the task ID, We have received the task ID, and now what we can do, we can pass this ID and create a async result function, async result, and oh, come on, async result, and I'll pass this ID, and then from here result, what I'll do, so from here S is ready, and ready. So S dot ready. So this method will tell whether the execution of that task is complete or not, and then I will, and then S dot result if ready, if S dot ready, that is if the like the result is how do you say, so if the task is complete and a result is saved inside the backend, in the result backend, then give me the result or return the none. What we are going to do, we are going to pass the ID, and then once we have the ID, we will create the async result function. This task dot delay creates a async result object. So from here, this async result, if you pass the ID, it will give you the information about that task. Like if this s dot ready will give you whether the execution of that task is complete or not, and then s dot result will give you whether s dot result will give the result which is the result of that task. And what I will do now, I will, let me see whether the worker has started or not. The worker has started, and now what we will do, we will make a request again, and once we have the ID, what we are going to do, we are going to make a request again, and this will be to HTTP localhost port 5000, and then it was get result, and then I'll pass the, and it should be a get request. This request URL was not found on the server. Let me check.
Get some is the method, sir.
Okay. Get some was coming. What happened? Internal server error. Let me do one thing. Okay, it's main.py here s.ready. The view function for getSum did not return a valid response. The function either returned none or ended with the okay. I have not returned that. Return in started, and now let's make that request again. Let's see what happens. You can see that it is giving 1020 because it is interpreting as a string. So this should be, if you go to the tasks.py, so it is interpreting this a and b as a string. That's why it is giving 10 and 20, because if you look at the request, we made a request with a and b, and both are, it thinks that this is a string. So what should we do is, like, we can pass it as a integer. Integer. So now, so if you look at this console of the Celery, you can see that this task was received. So what I said in the beginning, that this will run 4 concurrent requests. This can run 4 concurrent requests, not more than that, because we had in our, my computer is 4, like, has 4 cores, so it cannot run more than 4 tasks concurrently. So let me prove that it runs the task concurrently. So let me go here and make this request 6 times, and let's go and analyze the console. So 1, 2, 3, 4, 5, 6. I have made 6 requests. So if you see that it has received 6 requests, and it will, and if you, so let's wait for 30 seconds. It will give the results in 30 seconds, because we have written time.slip 30. So you can see that the previous task, so you can see that these 4 tasks has been completed, and the first task was completed by this fourth worker, and then second was second worker, third, and first. So the first 4 tasks is complete. Now initially these four tasks were running concurrently, because it cannot run more than 4 tasks concurrently, and 4 were busy. And then once these tasks were complete, these tasks started to run. These 2 tasks started to run. So the first, if you look at our Celery system received these 6 tasks, and first task was assigned to the fourth worker. I mean, worker with the ID 4. The first task, you can see the ID 33FA, 33FA 34. So this was assigned to the fourth worker, and the second task was assigned to the second worker, and third task was assigned to the worker with ID 3, and fourth was assigned to the first worker. So these 4 tasks were assigned. So all 4 threads were occupied. So these 2 tasks didn't run instantaneously. It waited for for the uh, worker to be free, and then once this task get complete, this task started with this task. So actually, all these tasks are going inside a queue. So this is a queue. So first come, first serve. So these 4 came first, so they were served, and these were completed. And once this fourth worker with the ID 4 was free, then the 5th task was assigned to it. If you look at this 5th task, this was again done by 4, and then the second worker got free, so the 6th task was assigned to it. So these 2 ran concurrently, and these 4 ran concurrently. So if you run this program in a single thread, the first one will take 30 seconds, and the second task will start after the 30 seconds. But because we are using this Celery, all these four tasks started at the same time, and then after that, once the worker got free, these two tasks started executing. So any question till now, because this is how the Celery works. So, and after that, whatever we will do in context of Flask application. So I'll explain you what is the problem with this approach. So any question till now?
So I have a bit complex folder structure. So I am facing issue with starting the Celery task.
Starting the
I
Celery task.
yes,
So that your Celery is not starting.
yes, sir.
I mean, in order to start the Celery, all you have to do, you have to like get the Celery instance. For example, this Celery app is our Celery instance for this application. And
Mm,
and
yes, sir. Sir, when I write that line worker import Celery app, the Celery app is not, I think, getting. Uh, Celery app is creating a problem, I guess.
why, if you have a module where you have created your Celery instance, you can import anywhere you want.
Hmm. So because I don't have a single main.py, I have my init.py where all the configurations are happening. So due to that, I guess the problem is happening.
Are you using factory function?
So I have just started what you told in the starting. I haven't used anything about that.
I don't know. It should not be a problem. So you just have to figure out where your Celery instance is.
So
And
can you help me at the last? I'll share my screen. You can.
okay, sure, sure.
Okay, sir.
So now the problem with this approach, the problem with this approach is like this task is not running in the application context. But in the application context means if you want to use like database, let's say you let me switch off my mobile.
होने की कोई जरूरत नहीं। हम ये सब अपनी इमेज के लिए कर रहे हैं क्या तुम हमारे साथ कल घूमने चलोगी?
Okay, so let's say you want to use the Flask SQL Alchemy. So for that you need the database URI, and that database URI is specified inside the application configuration, and that configuration will not be available if you are not using the if you are not and if the application if the code is not running inside the application context. Okay, so for that you need to run all our tasks inside the application context. So how do you configure your Celery app in such a way that your task will run inside the application context? So for that, what we can do is like we can like subclass our task. Let me start writing the code. After that, I'll explain you what I did. So diff create Celery app and create Celery app, and I will pass the application. So I am creating a factory function which will create a Celery app. and here class Flask task, and what I'll do, I'll import the task here, and I will subclass this task. And what I will do, I will redefine the call function. So the call function is a function. So in the Python, the call function is called whenever you will use a class instance as a function. Self, and then I'll use the args and args and args. So whatever you will pass to to this task will be like whatever the parameter you will pass. I mean, let me rejoin this because I am getting annoyed by that annoying noise. I'll just rejoin.
Sir, you're not audible.
Okay. Am I audible now?
Yes.
Okay. So what we are trying to do here, we are trying to run our task in a application context, so that we should have access. We could have access of all the configurations which are set for the application, like the database URI or any kind of configuration which you are using. So with app.app context, self dot run, and then I'll pass the args and args. What we are trying to do here is whenever we are calling the task, right now our task was not running inside the application context. So we will not be able to access the application configurations. So like in order to have the access of the application configurations, we need to run our task inside the application context. So what it will do, this is kind of a wrapper around the task, and then we will create this salary application here. Instead of here, we will create our salary application here, salary, and then I'll name this salary application whatever the name of the application or Flask application is. What we are going to do from the Flask application, we are going to call this app. This app is a Flask instance. So from the main.py, we are going to call this create Celery app with, and as an argument, we are going to pass the application. So the name of this Celery application will be the name of the Flask application which we will be using, and then uh, task, and the task class we will be using Flask task. This says that we are going to use the task instead of using the default task class. We are going to use this Flask task as a, I mean, we are going to use this Flask task. We will not be using our default task. We will be using the Flask task, what this Flask task does. It runs the task in a application context. And then what we will do, we'll copy this Celery app config, and I will be okay, and then return the Celery app. But the problem will occur here, Flask, inside this tasks, because what we had done is like worker, we have imported this Celery app from the worker, and now the Celery app is inside a function, so this Celery app will not be available. So what we can do is like Celery app dot set default. We can set this Celery app as a default application, and instead of using this Celery app dot Flask, the Celery a has a decorator called shared task. From Celery import from Celery import shared task shared task shared task. So now this task is not binded with a single Flask application or Celery application. This is the shared task, means this task can be like used by the multiple applications, by the multiple Celery applications. This task is not specific to a particular Celery app. For initially we like imported this Celery app, and then we were like creating this task for this Celery app, and now this is the shared task, means this is not specific to a particular Celery app. So you can use this task from like more than two, or like by the multiple Celery applications. And now inside the main.py, what we will do is like remove this Celery app, and we will create the Celery app is equal to, from worker we will not import the Celery app because Celery app is not available. Create Celery app is available now, and then create Celery app, and I'll pass the application, and let's again try to run this app. The first thing we will do, we will try to rerun this Celery worker, and these codes I have taken from this background task with the Celery. If you look at here, they have created a factory, the Celery app, Celery application factory, and what they are doing, they are running the task inside the application context, and they are passing the application. So whatever, so you are required to pass a Flask application to in order to create a Celery instance here. So all the tasks will run inside the application context of the application which you have used in order to create the Celery instance. Now what happened? Okay, so everything is listed here. So this is the, now you can see the app is this one, and this is the, this is the message broker, and this is the result backend, and we can run for concurrent requests. We can concurrent task which I showed, that if you will run 4 tasks, it will run concurrently, and if you will run more than 4 tasks, it the rest of the task will stay in queue, and as soon as the task queue, the task queue gets free, that will be assigned. Those tasks will be assigned, as I showed here. So our salary system received 6 tasks, and we had only 4 workers. So 4 tasks ran, and then once the workers got free, these 2 tasks were assigned, and they are being assigned in a first come first serve order. Now let's go and see. So now we have done all these things, and where is that underlined? Okay. So let's again make a request. Let's check whether everything is connection was refused. I think we have stopped the Celery, our Flask application. I hope you guys understood why we needed that why we needed to like subclass the task and create our own like task class just to run the task in the application context, nothing else. So if in your application you are never using the application configurations, you don't need to run run your task inside a application context. So now let's go and run this one. Yeah, still working. And if I'll go here, okay, you can see that here you can see that it has received the 6 requests, and you know how you can access the results of the tasks. So if you come here, you can see that the delay function will so this task dot sum dot this delay method returns a async result object, and then async result object, this will return a async result object, and with the id, and we are what we are doing, we are just returning the id of that async result. And what we can do that async, and when and inside the get some function, what we are doing, we are recreating that async result function, async result object, by passing that id. And after that, we what we are doing, we are you can always access the state of any task which was invoked. So from here you can see that s.ready will give you whether the task is complete or not. If not, then it will give you false, and if yes, then it will give you, and if yes, then it will give you true. And you can use this s dot result in order to get the in order to get the result of that task, which is stored inside the result backend. So show you a let me show you an instance where the app the task has been started but it has not complete. So this will give you a false, and this will be a none. So let me do this. Let me send a request, and now I have a ID, and here what I'll do. Okay, this will hopefully it will. Okay, you can see that the ready is equal to false and return result is equal to null because this task is not complete. You can see that this task has been received but not completed. And let me send that request again. This is still not complete. Okay, this is now successful. And now if I'll make a request, you'll see that okay, ready. Maybe I have made a request a error here. Yes dot result. Maybe this would be a function. Let me check what should be the center apple by. Okay. The result is correct. Okay. Test out result. So if we have a result already, I mean that was right. Why didn't it give the result? Give us a result. Let me make the request again. Why null? Okay, maybe I have made some mistake here. Inside the task, return a plus b. Admin.py. It's not complicated too much. Start it again. Let's make the request again. And we have received the ID of the task. And we will make request to this one, this ID. It's not ready. Let's go and see the workers. Okay, why it's done. Okay, initially it was showing the shared task. Okay, ignore result is equal to false. Write the task by. Okay, it's ignoring the result. It just it's just starting the task, but it's not storing the result. By default, it is ignore result equal to true for the shared task. Now I'll have to restart this Celery worker. So if you have any question, then you can ask now.
So you will also show us on how this can be stored in the database, right?
Yeah, this can be done.
So for
Yeah,
front end, we are using Flask app, right? Where we'll ask the user to give a record, and then using Celery task, we'll accept it and then store it in the backend, right?
yeah.
Yes, sir. Now,
Front end is not the Flask app.
I mean,
So so the Flask is just giving you a URL to which user can send a request. So for now, our client, I mean the client which we are using is Thunder client. We are using the Thunder client in order to make a request. And then if you look at this main.py, so from the client we send a request to this endpoint, and then what this endpoint did, it triggered a task here, and that task is a Celery task. So it triggered a task, and then Celery system is running that task, and here we are receiving that task. So if you want to save something in database, what you can do, you can define that inside this task. So let's say you want to save the sum of a plus b inside the database. So you can write your logic here. I'll show you how you can do that. So for that we will need the SQL Alchemy. So let me install the SQL Alchemy. Okay. Root slash. Explain the whole flow again. From 5 plus from here it becomes slow. I don't know what is inside this live session 20, May 2023. It's making my computer slow. Okay, cd Celery demo. Then I'll install the class SQL Alchemy, and then I'll show you how you can like add the result of some task inside the database. And then so till then I'll explain the whole flow, what is happening here. So this is a client, this is a Thunder client, and client can be either your view application or browser or any HTTP client. And just for demonstration, we are using the Thunder client. And in your view application, the fetch API is the HTTP client. And for this demonstration, we are using the Thunder client. And what we are doing, we are making and we are using the Flask the Flask in order to serve our application, our Flask application. And inside our Flask application, if you look at the Flask application, we have a endpoint slash sum, like endpoint URL slash sum, and we are making a request from that Thunder client to this one. We are making a post request, and what we are doing, we are adding, and inside this endpoint, what we are doing, we are triggering a task, which is a Celery task. So this task dot sum, I mean this sum task is being run by the Celery. I mean this sum is being like run concurrently, which can run maximum of 4 tasks concurrently. So this is a asynchronous task. So, and after that, what we are doing, we are returning the ID of the task, and what we are doing after that, we are making a request to this endpoint, then get sum and then ID. And here what we are doing, we are recreating that async result function. So this sum dot delay will always result in async result object. So what we are doing, we are now recreating that async result instance object, and then what we are doing, from that object we are checking whether that a task has been complete or not. Dot ready will give you whether the task is complete or not. And then if the task is ready, that is the task is complete. So we are assuming that the task will take some time to complete. That's why we are running that task asynchronously. Otherwise, if it doesn't take much time, so we can run that task synchronously. So once that task is complete, we are getting the result of that task, and we are displaying it to the user. This one. So if you want to if you want to store some data inside the database, either you can use this function, you can get the result of that task, and then store it inside the database, or you can use the task.py. You can do it here, and this will not be a problem because we are running this task inside the application context. So our Celery application knows about the database which we are using in the Flask application. That's why we did all these works. All this work we did so that we could use the database URL. All these things are done just because of that, because we wanted to run all our tasks inside the application context, so that we could have access of the database URI, all those configurations which are set for the application. So now let's install Flask SQL Alchemy. Flask SQL Alchemy. Once this Flask SQL Alchemy is installed, what I will do, till then I will write the model. I'll write a single model, py, and inside this models.py, what I'll do, from Flask SQL, not from Flask SQL Alchemy, import class SQL Alchemy, and then I'll create a SQL Alchemy instance. cp is equal to SQL Alchemy instance, and then I will write my model here. I'll write a single model, and class, let's call it task1, and as you already know that you extend the model class, and then let's give this ID, and that ID will be a column, and it should be a integer, and this will be our primary key. Primary key is equal to true, and I will, what should I store? Sum is equal to db dot column, and db dot, it should be integer, going to store the integer. And then, so we have this model tasks. Okay. And then I'll have to add this inside our application. We have to configure that import that model inside our application. So from models import db, and then we have this Flask application here, and app dot config app.config, and I'll have to give the SQL Alchemy database URI. Database URI, database URI is equal to, it should be it is a SQLite database, SQLite, and then I'll name this test.db, and then I'll initialize our DB with the application instance. So db dot init app, and I'll pass the app. Now our application knows about this DB. Let me check whether this is installed. Yeah, Flask SQL Alchemy is installed. Now inside this task, let's say I want to store the result of a result inside the database. So what we can do is here, from models import db, so that db and task. Okay, so the task and db is here. Now what I can do is I'll store that task, I'll store that sum inside that db. So I'll create the s is equal to task. Okay, this is not the right thing to do. I will create a sum here, and inside the main.py, inside the task.py, I'll the sum, and I'll create sum with what was the name? Sum is equal to a plus b, and in case there is some issue, I'll just cast it as an integer, and then db dot session dot add s, and db dot session dot commit. Now, okay, what will happen is we will calculate the sum, and we will store it inside the database. But before that, I'll have to create the database. I'll create a temporary file, py, and inside this temporary file, I'll write the I'll create the database and just run and delete this. From models, import db and from main import app, and I'll have to with app context db dot create all, just to create all the database tables. And anything that is related to DB will not run until you run inside the application context. That's why we have written the app.app context, because I'll have to run it inside the application context. Otherwise, it will not work. So let me.
Sir, what is this application context? It is in environment.
Yeah. So whenever some application starts, or like whenever someone will make a request, the Flask will create two contexts, the request context and application context. And the application context will have all the data which is related to the application. And request context will have all the data related to that particular request. So related to application means, so the database, you all the things that you have specified inside your configuration is like application related data, like the database URI, or if you have used the secret key, then secret key. All those things are application related database. So I mean application related settings. So that application context has all the settings, and the request context will have all the things that are related to the request. Like if someone is making a post request, then it will have the request body and request whatever related to the request, that will be inside the request context. So it is both these things are created by the Flask itself. And whenever someone will make a request, all this I mean both the context will be created with with any request. And if you and if something is related, and if you are using something related to the application like the configuration, and if you will not run inside the application context, that will not be available to the code. That's why we are whenever we need the configuration, like if you'll use the DB instance, and if your like code doesn't know what is the URI of the database, it will throw an error that this code is running outside the application context. So application context and request context are created by the Flask itself, and it is created with every request. And application context will hold all the data that is related to that application, and request context will hold all the data which is related to the request. And whenever you will use the view function, like this one main.py, I mean this is the view function. So inside the view function, the application context is available. You don't have to explicitly mention that. So there are few places where the application context is pushed by the Flask itself. You don't have to like use that context manager here, the temp.py. So this like the function view function is I mean inside the view function, application context is already pushed by the Flask. You don't have to explicitly push that. But if you are creating a function which is not a view function, or there are some more instances where the application context is automatically pushed. But if you are using some function where application context is not pushed by the Flask, then you'll have to explicitly like like run that code inside the application context. And you can use this context manager with and this is provided by the Flask app.app context. So whatever you will run inside this context manager will have all the settings available which is related to the application. So for example, we yeah.
Sir, I think then is there an alternative for because can we write in main.py something like app.push context?
Yes, yes, you can do that.
Yeah.
By the application context and the request context, you just keep in mind that whenever some user make a request to the Flask application, it creates two contexts. First is application context, which has all the data which is related to the application. It is not specific to the request. And in the request context, it has all the data which is related to the request. And whenever you will need some setting of the application, and if you are not running it inside the application context, it will throw an error unless it is some view function or some more places where Flask automatically push the application context. But view function is one of them. So if you are using the like code which requires the application settings, then you will need to use this app.app context. Otherwise, it will throw an error that you are like you are doing something wrong. You are running some code outside the application context. So whenever you are running the code which requires the application setting, like the DB here, it will not work unless the application knows what is the URL of the DB. So you'll have to write it inside the app context. Okay, so let me run this temporary and I'll delete this. Python 3 temp.py. Hopefully it will create all the database tables. Yeah, let me go and check. We have the instance table now and we have the test DB, and let me go and check whether we have the table. Yeah, we have the table sum. So now I don't need this temp.py. Let's keep it, but I don't need this temp.py. Now we have the main.py, and now if we'll make a request to localhost sum, and if I'll make a request now, let's see what happens. So, and if I'll go to the database table, you'll see that nothing will be inside this sum because the task is running. The task is running. If you go to the tasks.py, we have written the time.sleep 30 seconds. That is all the code which is below this time.sleep 30 will run after. I mean, this code will run like the function first sleeps for 30 seconds and then starts executing. And if I'll go here and now I'll copy this and go to this one, and here I'll make a request. Why this null? Why this could be null? I don't know. It's a problem. Let me go inside the database and check what happens. What has happened. Task.py. It's always returning null. I don't know why. So let me remove this time.sleep for now. Let me rerun this worker so that I don't waste time. We are going to cover the salary bit after this. It will take only 10 minutes to cover. All you have to do is like change this worker to beat and it will start the beat. Salary beat. There is setting which is broker connection rely on. And now let's go and try again. Okay, not this one. Let's make a request again. Okay, and let's go and see. None is.
Sir, that 60-second time delay, we can keep 10 seconds also. No?
Yeah. I mean, it's not necessary to keep the time delay. I just wanted to simulate uh, which simulate the task which takes a lot of time in order to complete. That's why I just wrote time.sleep so that it doesn't return like instantaneously. Just to simulate the task which takes like some time to complete. That's why I wrote time.sleep. Print. Let me check on the application here. None was not coming before. Let me rerun the application and the. Did I miss
So
18?
I think the function name is add, not sum.
Okay. Function name is sum. And inside the main.py.
Okay, sir, sorry, I saw someone.
Okay. So let me restart the application and the salary workers again. Start. Hopefully this time we will get the results. Result.ready. I mean, this is not the problem because we have already tested this. So let me go here. Once check at the main.py /sum, that is correct, /sum, and we are making a request ALD sum main.py sum A and B is correct. And this should be fine. Let me again make a request. Okay, let's go to the workers. Come on, it's again giving us none. Let me check the configuration again. Celery config. Broker config. Try on startup. It should be to everything. We try on startup. Wrong, yes. Tasks. My task. Check. Everything is fine. I don't know why it's there. Task. And initially it was giving the result. Maybe I should try once. The only problem we are facing here is like the task is being executed and it is being successful, but the result is none. I don't know why. Maybe we have written something wrong here, or let me do one thing. Let me return hello from here. Let me check whether it works or not. So I'll here again started the task, so I'll have to restart this Celery worker. No result false. No result.
If not, we require to add int x plus int y like that.
This one? No, no, it's not required. It just says that this argument is integer, this is argument, and this function is going to return integer. Again, let's try. again returning none. The only thing we have not restarted is this Redis server. Shell task and the main.py. Tasks dot sum dot delay.
Sir, the value of accepted A and B from form will be string. Then where
Yeah,
we it to integer.
no, yeah, actually, even if it's a string value, you can still add them, but it will concatenate both the strings. So this should not be a problem. Did I mention it? Sending none. There is no error on the console. Okay, let me make the request here. Get some result is
So
none.
I have a doubt now.
Yeah,
Sir, I just and left out with the flow. Actually, in that work, not main, sir, there was one more works.py. Yeah.
worker. Yeah,
Oh, not this one also. Tasks.py, sir. There is
yeah,
one more function. I just saw a function where you have defined int x and int y, no?
yeah. It is inside the main.py.
Oh, it was somewhere like x and y. I didn't know where that function came from and
No, that is the different application.
okay, okay.
I just created the same application before, and then I created because I thought, even I mean, if I will like, get stuck somewhere, I'll take the reference. That's why I created.
Okay, okay, sir.
So I mean, it was working fine. I don't know why. Initially, it was giving the correct results here. So here you can see it is giving these results correct 30, 30, 30. Then it started delay. Let me try to print this. Print ANV. This is our last attempt. If this doesn't work, I'll just stop this from here. Stop this here, and we can discuss it sometimes. We'll go to the celery bit. Maybe I'll have to. I mean, this is related to some system because it was giving the correct result initially. Then it started giving none. Let's go to the console and see 10 and 20 is right. Why is that? 1 second. Let's just